what? This rolling motion. What all I discussed today, you have to do experiment. Today you have to do experiment. So you'll get a overall confidence. Then tie a string to that and try to pull. I'll give parallelly some supportive diagram so that you can verify and analyze it. Definitely at the end of today's class, okay, sir, what you thought are very simple. What is the use of this? Means already we know this. You have to comment like this. Our teacher thought, okay, these are simple things what he is taught. If you comment like this, I'll feel very happy. If you feel that teacher taught really very good rotation mechanics, it was very tough, then there's a problem with the teacher. When teacher teaches, you should feel easy. Things are very general things, especially this chapter is very generalized chapter. If you feel these are tough, then there's a problem is there. It's a very easy chapter, I feel. Okay, let's begin with this. Now, is it any point will become instantaneous center? No. At that instant, a point which is in contact will become instantaneous center for time being. So I'll proceed with this one. So a rigid circular disk of mass m and radius r is given linear velocity v0 released on rough horizontal surface at t equals 0. Find the linear speed, angular speed, time take attained, pure rolling, translational, rotational work done by friction when it attains pure rolling. Finally, when it attains pure rolling is asking. First, directly come for this. What is the type of slipping? What is the type of slipping? The moment you give, what is the, if V0 what is given? Center of mass is given linear velocity. If center of mass is having linear velocity, all points on object must also have the velocity of center of mass. All points should also have the velocity of center of mass. So what is the velocity of point P? Velocity of point P will be in this direction. Then come for this. Sir, how you can say? Because the point of contact P will have velocity towards right. How the friction should act? The friction will act in this direction. This friction, what it does? It will retard the center of mass. And also it will set up torque, no? So what is the torque? This is R bar, this is F, R cross F. How the torque clockwise? All of you, about center of mass, it will set up a torque. And the torque, how do it act? It will act clockwise here. So write alpha C. Now, what is this friction? Sliding friction, F equal to mu mg. So mu s is the thing, that one. So this friction, what it does, decreases linear velocity, increases angular velocity because of angular acceleration after some time. After some time. So what do we get? So these are the sequences that will take place. Now this friction, what it does, it will, let's come back to, this friction, what it does, it will decrease the linear velocity. So here, linear velocity V1. It will also, due to angular acceleration, the angular velocity will increase here. So this will be alpha C. Again, we'll continue. This is AC. Then I'll come and check it. So what are the velocities? It will have V1. Behind it will have R omega 1, which will be greater. Still what happened? The velocity of point P will be towards right. How the resultant friction should act? The resultant friction should act. I'll show it here because everything will get crowded here. Still, if I go and check it, V1 greater than R omega 1. No, definitely here only V0. So what is the slipping here? Shall we call forward slipping? No, also what is the slipping? Forward slipping. Like that, what this friction will do? It will keep on decrease linear velocity, and due to angular acceleration, due to torque, angular velocity will keep on increase at one instant. So what finally it will arise is at one instant. The velocity of center of mass will become v, angular velocity will be omega. Then what I go and check it, no, this will become v and this is r omega. Then what is the velocity of point P? V minus r omega. V equal to r omega. So velocity of point P is 0. Then what happened to friction? Friction will vanish here. So this is what it will attain, pure rolling. Shall I write in short, or for first question, no, I'll write it pure rolling. Again, after attaining pure rolling, what will happen to this particular rigid body? It will continue its pure rolling. It will continue its pure rolling. How long? As long as the surface is present. As long as the surface is present, as long as there is no external force acting, it will continue its uniform velocity pure rolling. How long, sir? As long as the surface is there. So like a 1,000 kilometer S, 10,000 S, 1 lakh S, from one planet to another planet, if there is a smooth surface, if there is a, though surface is rough, still it will continue forever. Because net force, net torque is 0, it will continue its uniform inertia of motion. So it's all about the velocity of point of contact. This one. Now, shall I say, now what happened? Pure rolling exists. Now you can discuss about I'll come and stand at point P, then what I feel? Then you feel the same particles which are rotating with angular velocity about center of mass, they are going to rotate about point P. Yesterday what we discussed, you can bring here. Now this will become instant axis of rotation. What about here? There's nothing like that. When do that instant axis of rotation will come into picture? When there is a pure rolling comes. When forward slipping, backward slipping, the idea of that will not come into picture. Time being. Got the idea? So what is our question now? What is this V, omega? How much of time it will take to attain pure rolling? How much of distance it has covered? So altogether it has started here. It has covered a distance. So after moving what distance it attain pure rolling, that all everything has to be determined. Okay, let's go get into the things what we know. Now, what is this friction? Acceleration shall we write minus F by m. Why minus F by m? Let me end up everything in one problem. It'll be no. What is acceleration? AC is equal to y minus F by m. Friction will retard the motion of center of mass. So this should be equal to mu mg by m. Mu g. Then what is the velocity v at time t? This v should be equal to v naught plus act. Keep this. Okay, let's come for the torque. The friction will set up a torque F into R equal to IC into alpha C. Able to understand writing this equation? F into R is equal to F into angle between R bar and F bar. How much it is? This R bar, this F bar, 90 degree. F into R equal to IC into alpha C. What is this torque? I'm defining about point C. I'll write it in bracket. What is F? Mu mgr, it's a disk, mr square by 2 into alpha c. So what is alpha c finally? Mu g by 2r, or 2 mu g by r. Then what is the angular velocity? At any, finally when it attains pure rolling, omega should be equal to alpha c, because only given linear velocity. So this should become 2 mu g t by r. For pure rolling, what is the basic necessity condition? V should be equal to r omega. V should be equal to r omega. Let me substitute here. Put 192 in 3. So what is V? V naught minus mu gt. What is r omega? Should be equal to 2 mu gt. So what is t is equal to V naught by 3 mu g. We got the time taken to attain pure rolling. Please do make notice here. After this much of time, what when it attain pure rolling? Now then, I want omega, I want V. So directly substitute the value of T here. Mu gt, what you can write? V naught by 3. Substituting this, mu gt. So this will become how much? 2 V naught by 3. This is something very important. Now, what is the distance covered by it to attain pure rolling? How to find out? Now you have to ask question like, how to calculate distance? Distance moved by the P or center of mass? Center of mass is enough, no? How much of distance moved by the center of mass? That what SC. But sir, this point will not move horizontally point P. How point P will move? Very random motion, no? After some time where point P will be here, after some time will be here, after some time will be here, of course. But it cannot be cycloidal path. What I said actually, because it is not a pure rolling. After pure rolling, it will be cycloidal path. The point on circumference, that one, cycloidal path here. What about this? Now, before pure rolling, when forward slipping is there, not cycloidal path and very complicated. After pure rolling, I think actually we discussed theoretical ideas at pure rolling. No, this is the forward slipping. In forward slipping, it's of no use to talk anything here. How do point will move? Point will move in some random path, not cycloidal path. They may ask you this also. Yeah, of course, it will move like this, but it will not be cycloidal. So let's calculate the distance covered. How to calculate distance covered? I'll take help of center of mass. What was the initial velocity of center of mass? V naught. Final velocity is this one. So I'll have many formulas here. V square minus V square, V naught square 2 AS. V is what? 4 V naught square by 9. You have everything content in front of you. Make observation very clearly. 4 9. So this will be 5 V naught square by 9 is equal to, so what is the total distance covered? It will be 5 V naught square by 18 mu g. This is the distance covered. All the important conclusions, I'm just highlighting it. Time taken. Let's see that. What about work done by friction? Friction will act opposite to displacement of center of mass. So it does negative translational work. And at the same time, why angular velocity increase? Because friction does positive rotational work. Translational work, rotational work. We are splitting up. We are splitting up into two parts: translation work and rotation work. It does negative translation work, positive rotation work here. So that will calculate this one. So now, how to? There's the one part. Now we'll go for the work done idea. Translation work done by the friction. Change in kinetic energy, change in translational kinetic energy, final kinetic energy mv square by 2, initial mv naught square by 2. So we know final velocity will be 4 v naught by 9 minus v naught square. Substitute this. Uh, 9 9 5. So again this will be m v naught square 5 v naught square by 18 negative. What about the rotational work by the friction? Final final kinetic energy of this one, omega square by 2. What is there's a disk, no? Mr square by 2 half into omega we don't know, but omega shall we write v by r because it attains pure rolling. What is omega? You can write v by r. Substituting this again, m r square get cancelled, so this will be m. I think for 4 will get cancelled, so m v naught square by 9. Is it, check it once? Is it positive? No. So net work done by friction. will be negative only. Check, it will be negative. So net work done by friction negative. That's why what happened, the kinetic energy of system gone decrease. And where do it has gone? Converted into heat between the rigid body, let it be insulated. It will convert into heat, that one. So if you go check the final kinetic energy, it will be less than initial kinetic energy. Now, what is this? It was a forward slipping, no? Till here, forward slipping. Afterwards, it attains pure rolling. And what will happen here? It will continue its pure rolling. Friction will vanish. So till where the friction will act, till it attains pure rolling. After this, it will become pure rolling. So here, what happened? No friction will act here. Any reason for that? Because velocity of point P, 0. No friction will act here. This is what happens here. Now, instead of disk, let me take a ring. Tell me, what will happen to this time taken? Will it be same? Will it be same? No. So when this becomes ring, tell me where the changes will come. The changes will come here, no? Look at IC. So IC, what you can write? MR square only. Then alpha C, what will happen? Will be only mu G by R. Then omega will change. Then definitely T will change. So all the rigid bodies, means ring and disk of same mass and radius will both will take same time to attain pure rolling. The answer is no. Will both will cover same distance to attain pure rolling? The answer will be no. What I did is for ring, what you should do, you should do this problem for, okay, already we have page, no? Let me, what you should do, that same idea, what will happen, you should extend for what? Ring. What is the time taken? Next, solid sphere, solid center. First problem is very important. So what all you should do, I'll leave the tabular column. Please, you have to fill up this tabular column. Next part of the problem, what you should do is like, there's a first problem. There's a way of learning. Rather than practicing many problems, you should focus on making things generalization. That's what the rotation mechanics way of studying things. You should not work out many problems. When you study, you should apply for other rigid bodies. So there's a rigid body. Now, what all you should try to fill up this column here. At least for 3 objects, you do it. What I suggest, there's a rigid body. Ring or cylinder, both are same, no? Ring or hollow cylinder. Both will be same, mr square, mr square. Then disk, solid cylinder, both will be same. Then what is left over now? Solid sphere, hollow sphere. All are having same mass and radius r. What is the moment of inertia? You know it. Mr square by 2, 2 by 3 mr square. Then what is the time taken to attain pure rolling? When it attains final velocity, distance covered, work done by the friction. What we did is, for ring, what we did, V naught by 3 mu G, 2 V naught by 3, distance covered 5 V naught square by 18 mu G. Anybody? Net work done by friction. Net work done by friction.
Minus 3 mv naught square by 18.
5 mv naught square, huh?
No, sir. Minus 3 mv naught square by 18.
Okay, ma. Yeah, thank you. You see this? This will be friction. Now you go for this. So what you're going to do? You're just going to replace alpha. I see here. That's all. Nothing to do with the problem. Omega will come different. Again, this method is same. Okay, this is one method is what I have shown here, like and all. And there's a one method is what I am showing it. So this is the way of learning things. Huh? All rigid bodies will not take same time. If you want, you can try for this. So what is the this now? Mr square. Alpha will be 2 mu g. Omega you got 2 mu gt. I think from here only the 2 will not come, no? So time taken, how much it will become? V naught by 2 mu g. Sir, how you are writing? Here 2 will not be there. That 2 will not be here. That 2 will not be here. That 2 will not be there. So V naught by mu g, that one. So here V naught by 2 mu g will come. V naught by 2 will come. V naught by 2 means how much it will become? V naught by 2. So time, finally it will be. Try to work out. I just shown. So what is the time taken? You take a ring of mass m and a. Both are, all the rigid bodies are having same mass, same radius. The shape is different here. Then what is the time taken to attain pure rolling? Different rigid bodies will take different time to attain pure rolling. That's what the conclusion. Agreed? This one. So try to check for solid sphere, hemisphere. Finish sure. You're in far better position. Now this is something, sir, like we are not that good in torque, everything. Is there any still easier method? That's what you can ask for teacher. Is there still any easier method? Yes, we do have one easy method. Like what I discussed, conservation of angular momentum. The same conservation of angular momentum is what you can bring it here now. Oh. Let me copy same diagram. I'll show by another method what we discussed now. No, another method is what I'm bringing. What is another method is like, I'll go for conservation of angular momentum. Because if net torque is zero, what is angular momentum is conserved. So then what about what point? So look at this rigid body. It is having only translative motion. So I'm going to, about which point is conserved. I'll say about the point on a ground. So let's go for the yesterday's class, what we discussed, no? Conservation of angular momentum. That is what I'm going to take LPR now. So you can avoid you can avoid all the mathematics here. Yeah.
Sir, here there is a alpha C, right, sir? I mean.
Wait. Listen. Give some time for me to, let me first share my ideas, then you can question me. Let me conclude. Okay, no. I'll say angular momentum is conserved about point G. What is this, sir? Like you said, angular momentum, net torque is zero, but here there is a torque is acting. I'm going to say that an angular momentum is conserved about point G or about point P. Both are same. Let me start with this one. LG Z initial should be equal to LG final I. Angular momentum about an axis passing through point G and perpendicular to plane of motion. Initial angle is equal to final angular momentum. So how come friction is there? Say, though friction is there, so what friction will do? Will intersect axis of rotation. Where is axis? Axis is here, Z axis. You assume this is the origin. This is X axis, this is Y axis. I think I can't show more than this. You should be able to understand. The point G is like some origin, better you call. The point G is origin, because if I write O, you'll get confused, because some books they're given center of the disk as O. So therefore I'm writing this one. Let G this one. Let G be the origin. So to make clear, fine. Okay, look at now here. This is x-axis, y-axis, this z-axis, no? No. This friction will intersect axis of rotation. Sir, what about normal contact? There's a normal contact is there. Weight is also there. There'll be torque due to this S. There'll be torque due to weight. In what direction? This is mg. This is r. Clockwise. And n how normal contact. This is r bar. This is n anti-clockwise. And n equal to mg. We know the basic idea here. So therefore, what will happen to the net torque due to resultant of n and mg? Due to weight, it will be clockwise. Due to normal contact, it will be anti-clockwise. Due to friction, it will intersect axis of rotation. Torque due to weight and normal contact will be equal and opposite. So what is the net torque about point G? Is 0. Why we are conserving angular momentum about this point is, so let me write first. Net torque is 0. Reason for that, F intersects axis of rotation. This will intersect axis of rotation. What about torque due to normal reaction? Will be clockwise, will be anti-clockwise. I think I'll write one mathematics here, so that will be easy. There's a fundamental one. Let me put like this here. Torque due to friction. Torque due to normal contact. Torque due to mg. Due to this, it will be 0. Any reason for that? It will intersect axis of rotation. What is the torque due to normal reaction? N into say some x anti-clockwise. Torque due to weight, mg into x clockwise. And we know n minus mg equals 0. So therefore, what you can write? So I can conserve angular momentum. About what point? About axis passing through point G. So then applying conservation of angular momentum, I think I need some space. Please do fill up this tabular column. It's a very important way of understanding things. Let's write conservation of angular momentum. How to write that equation? The first time you are seeing this conservation of angular momentum, no? Yeah, we have everything at one place. This is that point G. I indicated everything in the diagram here now. So let's write the equation now. Lg Zi equal to, what is Lg Zi? Angular momentum about this one. So this should be equal to m Rg cross velocity of, what is velocity of center of mass? Is V naught. This should be equal to, finally it attains pure rolling about this particular thing. So instead of all this, I think I told you, no, how to write equation directly. You should write what is the equation instead of going for mathematics here. Angular momentum due to translatory motion plus angular momentum due to rotatory motion, final, initial, sorry, and angular momentum due to translatory motion plus angular momentum due to rotatory motion, final. Now what is the angular momentum due to translatory motion initially? mv naught r only, clockwise. There's no rotatory motion, 0. This one. So it is like, actually it will come like this. So what is that? R sin theta will become capital R. So only due to translative motion about point G, how much will be mv naught r, only due to translative motion of center of mass, no rotatory motion initially, 0. Finally, what is this one? mvr. But sir, point G is here, s, let it be, no problem. That r sine theta, what will become? Will become only capital R. So it will become mvr plus angular momentum due to rotating motion about center of mass. This will also be clockwise. So this will become mv naught r. So what is this? This is a rigid body disk, mr square by 2, and for pure rolling, v should be equal to r omega. Check it now. mr get cancelled, so v naught, v plus v by 2. Finally, what is v is equal to 2 v naught by 3. We didn't do any of that method. Even you need not to bother about direction of friction. No need to make a guess, forward slipping, backward slipping. Directly you'll get the answer. After getting v, what happened? Increased or decreased? Check it. V less than v naught, no? Then who has decreased the friction? Then you can make a guess of friction. Friction will act backward. Are you getting this? A reverse way of doing problems. If you go for first method, you should be very good in what? Predicting the direction of friction. For that, you should look at the velocity of point P. You should calculate velocity of point P. The friction will act opposite to opposite relative motion, opposite to velocity of point P. So friction will act backwards. So you should be very good in getting the predicting the velocity of point P, opposite to velocity of point P. The friction should be projected. But here, what happened? Nothing to do. No, I didn't bother anything friction. I'll check the final velocity. Final velocity less than initial velocity. So therefore, friction will act backward. Problem solved. Once I know V, I can bring the time taken. How to bring time taken? Because we'll decrease this, the friction only. So what is the retardation? Mu mg or mu g. Then I'll write the equations of motion and solve it. This is the conservation of angular momentum. In books, what happens, instead of showing this, they're telling about point P. I think one of the same. No? Yesterday I concluded, either you find out angular momentum about axis passing through G or P, both one of the same. Slowly, gradually, I'll shift the problems, this particular thing. Or if you're convenient about G only, you can apply it. But it's the best practice always to pick up the point of contact. Because what you calculate angular momentum about axis passing